Advent of Code Day 8 using OpenRefine. So the Day 8 puzzle, I've had a look at this, but I've not done it yet, so get to see me try it in real time. So what we've got here is a grid of numbers that represent tree heights, and what we've got to work out is if tree is the trees that can be seen from the edge of the forest, and the rule is that essentially if there's no taller tree or a tree of the same height or taller between it and the edge of the forest, then you can see it. So trivially you can see all of the ones that are on the edge of the forest because there's nothing between you and them. And then if you go in one row or one column, then if it's taller, so for instance this one can be seen from the left hand side because 2 is shorter than 5 or less than 5, and from the top because it's greater than 0, but it can't be seen from the bottom because there's another 5 here which would block the view, and it can't be seen from the right because there's another 5 here that would block the view. So basically that's it, that you can see things if they are taller than everything else in the row or column you're looking down. So we have a puzzle input which looks like this. So this is the grid of numbers, this is the tree heights, and we have to work out how many trees are visible from outside the grid. So we'll take this and put it into OpenRefine. I think we'll start with it just coming in as a single cell per row. So let's call this the forest. Okay, so I had to think about this, and I think the way to do it is not to leave them like this, but to think about every number is either in a column, well, it's in a column and a row. And so we want to know for any particular number, is it the largest out of all the numbers to the left of it, or the largest out of all the numbers to the right of it in the same row, and the same with the column up above it or below it in the column. So rather than leaving it like this, what we'll do is we'll transform this so we get, so first of all we can split it so we get each number by itself, and what we want to do is I want to know which column and which row it's in. So the row is, we've put each rows come in as a row, so there are 99 rows, so actually it's just the row index plus 1. So the row index plus 1, so we're in row plus put that in brackets. So let's say, and then we've got one of those separator, just a separator of some kind, and then we've got column. Okay, so we want to work out the column that we're in, so actually let's we've got an array here, so let's iterate through this array. So it's going to be for each index, which means we get a counter as well, so I is the counter, V is the value. So we're in column that'll be I plus 1, and then plus separate again plus the value That hopefully, so this is row 1, column 1, row 1, column 2, that's right. So we'll join those together with another different separator. So now we have all the rows and columns. So if we split this up by, if we split this into separate cells, so we treat this as multi-value and we use that separator there, then now we have each tree value in its own row, and we can split this that way. And so now we have the tree height is here, so let's call that tree height. And then we have the column here, and we have the row here. So if we want to have all the rows, so let's see, so we have 99 trees in a row, so the first 99 are always in row 1, then we start row 2. So if we blank down, we now have records. So row 1 is one record, row 2 is another record, and you might be able to see where we're going with this. So essentially, because we know all these are in row 1, we can now work out for each one, is it the largest, or are there any to the left of it or to the left of it in the row that come before it in the sequence that are larger or the same, or any after? So what I'm going to do is add a column based on this column, and we'll call this visibility. And what I want to do is take all the values in this record, in this column, in this record. So that's row.record.cells.treeHeight.value. So those are all so for each of those, we want to know so we can do for each index again, and then we get counter. That's going to be useful, so that's the counter. So for the value v, actually let's make this into let's get this array to start with, so don't have to keep typing it again. So let's call this trees. So for each trees, we'll call it T just to keep it in theme. We want to look at things to the left of that, so that's trees dot slice 0 to I. And we want to know, we want to filter that, so we want to test, so for each index, so the test if the trees are all so if we have filter trees left, and then so we want to allocate that to just a v, so let's say if T, that's the height of the tree, is, if we filter out all the ones where it's smaller, so if it's v is less than, no, when it's bigger, so v is greater than or equal to T. So work this out. So what I want to do is, okay, so that's the filtered. So if the filter is dot length so if it's 0, then it's visible, because we're testing to see whether anything to the left is, so if we take out all the things to the left of it that are bigger than it, do we end up with 0? So we should find that with 1, everything to the left of it is 0. With 3, everything to the left of it is 0. With 3, not everything to the rest of it is 0. So we get true, true, false. And so that, I think, is, we've got yeah, so that looks right. So what we want to do is, so that's our visibility. So we want to extract the right one for the row. So that's the index in the record. So if we just use row index, oops, there you go, should, there we go, one too many brackets in. So that should give us the answer for each row. That works for the first record, but not the second one, because now the row index is 99, and we want it to go back to 1. So we actually have to have the record. So we want the minus the record. What's the I have it here. The record, the from row index. So minus, and that should work for all of them. So yeah, so this is taking the first row index for the record, for each record, away from the row index. So we reset to the 0 each time. Okay, so that's the visibility essentially from the left of the row. Now we want to transform this, so we want to now do the same calculation but for the right of the row. So rather than doing the slice from 0 to I, we want to go from I plus 1 to the end that's implied, so we don't have to put in an end one. The rest of it is the same, but we want to do the current value. Sorry. I want to do the current value or that, so because we want to get, if it's already true, we want to preserve it. So essentially all these together, the current value, and if that's true, and this is true, then it's true if it's one of them. As long as one of them is true, we'll get a true. So that's the rows done. Now we fill this back down and we move that to the beginning and blank this down. Now blank this down. We have to sort it by column first. Let's just undo those couple of blank downs because we don't need them. Right, so now we sort by column name, we apply that permanently, we blank down, and now we have them in the columns instead of, so a record per column instead of a record per row, and we do exactly the same now. So we want to transform this and it's or value that. So that's the first way round, and then we do the same. So we transfer, and then it's just a repeat of that. So okay, now just fill this down to fill them back in. So this is true for 1700 trees, false for 18098. So hopefully 1703 is our answer. 03. It's the right answer. Right. So part 2. Obviously haven't seen this yet. Advent of Code Day 8, Part 2, and I've really struggled with this one, made lots of mistakes, but I now have solved it, and I checked the answer, so I know it's correct. So taking these tree heights, we've got to work out how far you can go along a row to the left and to the right, and how far you can go along a column up and down before you encounter a tree that is the same height or greater. So essentially numbers the same or larger. So if we take this 5, we can go 2 right along the row because we don't hit a larger tree or a number the same or greater, but we can only go 1 to the left before we do hit that number that's the same. And going down 1, 2 until we hit the number that's the same, and going up 1 until we get to the edge. So essentially we've got to calculate those numbers for each tree. So how far you can go to the right before you encounter a number as large or greater, to the left, up and down. So the way I've been doing this is essentially to add a column for each one. So I've added trees to the south. This is the the number of trees to the south, or so down the column, that can be counted before you hit one that's the same or larger. So here, like if we have the tree height of 1 and we're going down, this is the rows. So let me just go back to the other order. So here we have column 1, tree height 1. So we can go north 0 because we're at the edge, and we go south until we hit a tree that's larger, which is 1. So immediately we hit the tree that's larger, and so tree south is 1. And if we look at another example here, this tree here is height 3, so we can go north 1, 2 before we hit a tree that's larger. You can see that's the number there, and going south 1, 2, 3, 4, 5, 6 until we hit a tree that's the same size. So that's the 6th. So I can do this, and what I did was actually I started doing this with a much smaller grid. This is from the test data set that they give you, so just 25 rows, and I worked it out and checked my scores on that smaller one, and that's given me a set of transformations that I can apply. And so what I'm doing here is now going to add the east and west ones, and this should, I better just get them. So one of the things that tripped me up several times was getting the rows in the right order. So we want to just make sure we've got by row, and then we've got them in the records. So now if we apply that logic from the other place, we've already done the blank down, so we don't need that. Okay, so performing those operations, that should add our trees west, trees east. So that's all of that's adding the similar columns, multiplied them together with the scenic score. And because I'd already done it in this project, I could just extract and apply, which is one of the really nice things about OpenRefine. But apologies for not showing all of that because it was a bit of a nightmare getting my logic right. So now I just need to sort. Let's what have I got a sort on here? Oh, it's sorted by scenic score. So let's. No, didn't mean to do that. This is the kind of mistake that I'm making constantly. Right, so let's fill this down. Now we sort by scenic score. So by the numbers, we get the largest first. 496650 is the answer. And if I go down, you can see that is the answer I entered, and that was correct. And that is day 8 done.